welcome to this lesson about Azure and Entra ID black box methodology. During this lesson, we are going to be explaining the steps of the black box methodology and how to perform them in Azure and Entra ID environments. You should learn how to combine all the knowledge you have learned in the previous lessons in order to perform a full attack against an organization using Azure and Entra ID. Moreover, we are also going to learn where to find Azure tokens in a PC if during a red team you manage to compromise a developer machine. I hope you enjoyed this lesson and learn a lot. Here you can find a typical cyber kill chain for a red team attack. Some people will add or remove some steps, but the idea is always the same. The first step is the discovery and enumeration. In this step, the attacker is going to try to find as much information as possible about the target organization. This could be done by checking the organization website, checking for open buckets, checking for open ports, checking for subdomain takeovers or open services, and in general, anything that could give the attacker some information about the organization and potentially some access to it. The second step is the exploitation. In this step, the attacker is going to try to get a foothold inside the organization. This should be done by exploiting some vulnerability found in the previous step, or via a phishing attack, or a physical intrusion, or some social engineering, or whatever actually that give us access. The third step is the internal enumeration. In this step, the attacker is going to try to find as much information as possible about the Azure and Entra ID environment of the organization using the compromised access, of course. Depending on the access the attacker has, he is going to be able to obtain more or less information. During the fourth step, we are going to be performing post-exploitation, persistent, and privilege escalation attacks. The order doesn't really matter, so you don't need to trust this wheel. The order doesn't really matter. You don't need to do a post-exploitation or persistence before a privilege escalation. You can do it. You can do whatever you think is better for the red team. So this step depends completely on the information we gather enumerating the environment, although the information from the initial enumeration could also be useful. The goal of this step is to try to maintain persistence inside the environment and to escalate privilege or perform some post-exploitation actions that will allow an attacker to access sensitive information or obtain further permissions inside the environment. If a privilege escalation is successfully performed, the attacker is going to be able to access more resources in the environment, and therefore he should start again the enumeration of the environment, and based on the new permissions he has, he should try to obtain more persistence, check for interesting post-exploitation actions, and escalate privileges again. The attacker should continue this cycle until he is able to access all the resources in the environment, or until he cannot see how to compromise more resources inside this environment. Finally, the attacker should think about the potential profits he could obtain from this access he got. Of course, this is interesting from a red team's perspective because you need to show the organization what could have happened if you were a real attacker in order to show the value of your work. So let's get started checking each of these steps more in depth. Okay, so let's get started with the first step of the black box methodology. This is discovery and enumeration. One of the first things you need to confirm before moving forward is that the target organization is using Entra ID, and we can easily do this. Moreover, in that case, it is also possible to get the tenant ID of the organization, other domains using the same tenant, because you know that you can assign to the same tenant different domains, so we can also get this information, get the login options of the users inside this tenant, check if desktop signing is enabled, and even get the email configuration of the organization. Moreover, with this information, there are several interesting attacks we could perform. For example, we could try to enumerate valid email addresses inside the tenant, and then we can try to brute force their passwords. Or in order to avoid the lockout mechanism, we could try some password spraying attack over all the emails found. However, note that it is possible to have password protection in Entra ID configured in order to prevent common passwords, which will make this brute force and password spraying attacks a little bit more complicated. Of course, as another option, we could try to perform a phishing attack to get credentials of the user we have discovered, or to make them accept an OAuth application that we control, which is going to be asking for sensitive privileges. Moreover, in order to try to get a foothold inside the organization, we should also check other OSINT sources. For example, we should check for potential GitHub leaks in the GitHub repositories of the organization and in the personal repositories of the workers. Here we could find sensitive information like API keys, passwords, emails, Azure service paths, SaaS tokens. Well, in general, any OSINT source that could contain relevant information about the organization should be checked. Okay, so moving forward, in this black box methodology, we are going to be explaining each part, mentioning which attack could work that will allow us to move into the next step. So in this initial access, let's suppose that a password spraying attack worked. Okay, so let's now do a quick demo showing how to perform all the actions we just commented, so you learn how to perform this kind of enumeration. First of all, we need to know if a domain is being used inside Entra ID. And for this, one of the easiest ways to do this, to detect this, is to check the TXT records of the subdomain we are suspicious that might be used. And here you can see that this azure.training.hacktricks.xyz is having this Microsoft tag, and this is something that Microsoft.Entra ID asked me to put in order to show that this subdomain belongs to me. Well, this basically means that if you find this kind of tag in other subdomains, it probably means that it's being used by Entra ID. However, we have a more certain way to notice if a domain is being used inside Entra ID by looking into login.microsoftonline.com / the domain you are checking / well-known / OpenID configuration. And if you get information about the domain here, you know that this is being used by Entra ID, and you can even find the tenant ID that is being used inside this domain. And you can also see other information such as token endpoint auth method supported, response method support, mode supported, and so on. You can get some information about the tenant. The most interesting one is potentially the tenant ID. Okay. We can also, instead of using curl, we can also use a tool that is called AAD internals. So there is a tool called AAD internals that is going to be having a lot of interesting commands in order to enumerate an Entra ID domain externally. So we can use this cmdelete that is called get AAD int tenant ID, and indicating the domain, we can get the tenant ID of this domain. Moreover, we can also get other domains that are using the same tenant ID. And here we can see that this azure.training.hacktricks.xyz is using the same tenant ID as carloshactricks.onmicrosoft.com. So this is super useful in order to know which domains we could try to brute force later in order to find valid usernames, valid email addresses inside this tenant ID. And actually, we can start doing this. So we can check also the command that is called invoke -aad int user enumeration as outsider, which is going to be allowing us to enumerate to check if an email is valid or not. So checks whether the given user exists in Azure ID or not in Entra ID, returns true, false, or empty. Actually, this tool have 4 different methods it can use in order to check if an email is valid or not. It has the normal method, the login method, autologon, and RST2. So the normal method seems currently work with all tenants. Previously, it required desktop SSO, account seamless SSO to be enabled for at least one domain. The login method works with any tenant, but enumeration requires enumeration queries will be logged into Azure AD sign-in logs as failed login events. So it's not super interesting to use, because as attackers, we want to generate the least possible amount of logs, especially in this initial phase. We don't want to just get discovered while we don't even know which emails are valid. Then you also have the autologon method, which doesn't seem to work with all tenants anymore, probably requires that desktop SSO or direct sync is enabled. And it also have this RST2 method that we don't have it described here, unfortunately, but you can check more information about it on the internet. So far, let's start taking a look to how this is working. So we can indicate a username that we want to check if exists with this command, invoke AD int user enumeration as outsider. And here we can see that this user exists, and we know that this exists. We can also check another user that we know that exists, and it is finding correctly that this username exists. Something that we can also try is to check this same username inside the domain with a different domain address that is valid inside the tenant ID, because we know that these 2 domains are being used inside the same tenant ID. So this domain and this domain is used inside the same tenant ID. But as you can see here, a user email is related to the specific domain that it was used to create the user. So even if this username exists, this username with the other domain used by the tenant does not exist. And this is something you need to know. It is important that if you find different domain addresses being used, you might need to try to brute force all of them, or the main one, as you prefer. But there might be different users in different domains inside the same tenant. And of course, if we try to check for a fake one, it says that it doesn't exist. We could also use other methods, such as the method login, and it's going to be showing that this user actually exists, but this is going to be generating the logs we commented before. We can also check the autologon method, which doesn't find it because we don't have this directory sync or single sign-on enabled inside this tenant ID, so it doesn't find anything. And also we will use this RST2 method, which indicates that this user does not exist, because actually it does not exist as we are using this other email as we showed before. But if we get the real domain this user is existent in, so we change, let me change the domain name. Okay, I want to copy this one. We can see that it exists and it is working. Of course, we can also do these actions passing a file with the usernames we want to check. We don't need to be checking them one by one. So we can just execute this, and as you can see, it managed to find that these are existing, these two are not existing. There is another interesting tool that is called O365 Spray. So we can go to inside this tool that can also be used in order to perform username, email enumeration, and also attacks such as password spraying. So for the moment, we can just check how it is working in order to find if a username is existing. In this case, we need to indicate the username here and the domain name here, and it's going to be just creating the email address and checking if it exists. And of course, we can also create a list of potential emails and pass it into this capital U parameter, and it's going to be getting those email addresses and it's going to be checking them. We actually pass it 3 different email addresses, this, and this. We know that these 2 exist, but this one doesn't. So we get running user enumeration against 3 potential users, and it found 2 valid ones. So it managed to discover the valid ones. So I'm sure you have already executed most of these actions in the labs in order to find the permissions you're having and so on. But let's do a quick demo. I have already logged in the Azure CLI and in the Azure PowerShell module with a user that is not administrator over Azure, and we can just try to figure out some interesting permissions out of it. So for example, if we go here to the Azure PowerShell, we can start checking, or we can start executing this get AZ resource. And with this, we are going to be able to see all the resources where our user is having some kind of access over. And here we can see that we have a bunch of them, although if you take a look, a lot of them is going to be related to virtual machines. So we have a network security group, disk, public IP address, bastion host, components, connection, network security group. Well, this basically means that we are potentially having some kind of permission over a resource group or over a subscription, and therefore, well, these permissions are going to be inherited in all the resources. If we were having a permission, a role assigned over one specific item, one specific resource, and that's all, we wouldn't be seeing all this stuff here. And well, because it's weird to just assign directly something to a specific disk or to a specific security group, well, if you see a lot of junk, let's say junk resources, it means that you're having some kind of permission assigned over a subscription or a resource group or even a management group. But we will be figuring this out. Okay, so the same way we have executed this get AZ resource and we got some information about the resources we can see, we could also contact this API indicating the subscription, and we are going to be getting the information about the resources that we can see inside this specific subscription. Here we are going to see, well, a very similar data, although in this case we have a JSON format. And we can see, I don't know, this storage account, solutions, components, another storage account, environment, component, server farms, more storage accounts, network interfaces, virtual machines. We have access to some virtual machines. This is of course interesting. Some disks, virtual machine extensions, network interface, host pools. We are going to be having some access over a host pools, which is of course interesting because this means that they are using, well, then that in this subscription we are using some virtual desktops and potentially using virtual machines to prepare to offer these virtual desktops. So it's interesting we are having this kind of permissions. Later we will check more. Well, at the end, you can just check all the resources you are having some permissions over. And then moving on, we will start checking all the assignments, all the role assignments. So we can execute this get a set role assignment, and we are going to be able to see all the role assignments that are been happening in the default subscription that we have configured inside this Azure PowerShell module. And as you can see, there are a bunch of them. So this is not ideal, definitely, from an attacker's perspective, which is only interested in the permissions he's having. How could we reduce this? Okay, so previously we found, okay, this interesting desktop virtualization user. Actually, this is a very interesting permission that I was expecting to look for after. So here we have this scope. The scope is an application group inside the virtual desktop. The object role definition ID, object ID. Our user, this is the user that I have authenticated with, has this desktop virtualization user over this application group, which potentially means that this user is going to be able to access some virtual machine inside this host pool or of virtual desktops, basically indicating that we might be able to escalate privileges by logging in inside some virtual machine. That's definitely interesting. But moving on with what we were expecting, actually we can just get this scope and try to get only the permissions assigned into this scope. So we'll be able to see more clearly these permissions. Okay. Actually, let's do something. Let's clean this a little bit. And now you can see that, well, we still have a lot of permissions being responded in the response, but well, now it's easier. We have this user being a desktop virtualization user, this user which is administrator being user access administrator, this user is also user access administrator. So as you can imagine, all the users that are admins inside the subscription, they are going to always be having some permissions over the resources. But here, as you can see, it will be much easier to just filter or to just search for the user we have compromised and check the permissions we are having. We have that permission, we have role definition name, this other permission, we have the reader permission, the reader role, sorry. We have also this custom role Carlos, that later we can check what this is about. And we have also this desktop virtualization user that we checked before. And this also Carlos role delete me. Okay, so it is very interesting. We have managed to find all our permissions inside a relevant service, a relevant resource, which is not ensuring that we are going to be able to access a virtual machine inside the host pool of the virtual desktops that is using this application group, but having this permission make it highly probable inside Cloud HackTricks. And supposing we have compromised everything, or that we cannot see how to compromise more resources in the environment, it is time to think about potential profits. If you're a red team, your profit will be the satisfaction of having compromised the environment, and you could start writing your report. However, in order to make the management of the organization really worry about what could have happened if you were a real attacker, you need to know what you could have done with the access you got. The most common for-profit actions that real attackers will perform are mining cryptocurrencies, dumping all the data and then ask for a ransom to not leak it, or selling the data directly, kill everything causing a DOS over the whole infrastructure, selling access to the infrastructure, using the infrastructure to perform other attacks. They use KMS keys in order to encrypt all the data and ask for a ransom to decrypt it. So basically, with this information, you could now start writing your report and make the organization management worry about what could happen if an actual attacker would have performed the red team that you have finished.